Welcome to Wednesday, April 15th, 8.2 notes. We're going to be talking about measuring angles and arcs. So a central angle of a circle is an angle with a vertex in the center of the circle. Its sides contain two radii of the circle. So if I take a look over here in my circle P to the right, I know that angle APC is a central angle of circle P. So if I take a look from A, P to C, this angle is at the center of the circle, and AP and PC are both radii of my circle. So that is what we call a central angle. The sum of central angles. The sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. So here, angle 1 plus angle 2 plus angle 3 will add up to be 360 degrees. Remember, all the angles of a circle will add up to be 360 degrees. So let's look at our first example. It says to find the value of x. Well, if I take a look, I'm going to highlight from R to V. We know that that is a diameter. And the diameter, what you're going to find out, is half of a circle. I don't know all the angles here, so I'm going to go on and say, well, if this is half of my circle, then that means that 8x minus 4 plus 13x minus 3 plus 5x plus 5 equals 180 degrees, or half of that circle. So 8x plus 13x is 21x, plus 5x is 26x. Minus 4 minus 3 is minus 7, minus 7 plus 5 is minus 2, pardon me, which is equal to 180 degrees. Now, I'm going to go on and add the 2 to both sides to help me solve for x. So I get 26x equals 182. So I'm going to take this 182 and divide that by 26 now, and I get that x is 7. I'm going to look at example number 2, and I'm going to do example 2 in very much the same way. But this time I do know one angle. I know that this is angle 75 degrees for the central angle AZB. So I'm going to say that 75 plus 5x minus 5 plus 7x plus 2, that's equal to 180. 5x and 7x is 12x. 75 minus 5 is 70. 70 plus 2 is plus 72. That equals 180. That means 12x will equal 108 when I subtract the 72 from both sides. So 108 divided by 12 gives me that x is 9. So an arc is a portion of a circle defined by two endpoints. A central angle separates the circle into two arcs with measures related to the measure of the central angle. So if I take a look over here at this, I have a red arc right here. So this red arc from B through D to C, I'll highlight that here in red. That is an arc right here. And then I have another arc, and that is this blue arc from B to C. And it says that whatever the central angle will be, that angle measure is that arc measure. So for instance, if I was to say that this angle BAC was 60 degrees, then that means that B to C, that arc BC is 60 degrees. And we know that a circle is 360, so that means that this arc right here in the red would also be 300 degrees. So the measure of this central angle is the measure of the related arc. Now we name arcs. How do we name them? Minor arcs are named by their endpoints. A minor arc is the shortest arc connecting two endpoints on a circle. The measure of the minor arc is less than 180 degrees and equal to the measure of its related central angle. So a minor arc, if you would, is this little bitty, it's the shortest distance between the 2 points. A major arc is the longest arc connecting two endpoints on a circle. The measure of a major arc is greater than 180 and equal to 360 degrees minus the measure of the minor arc with the same endpoints. So here I have a major arc in the red. And a semicircle is simply a half circle, and the measure of a semicircle is 180 degrees. So getting back to naming these arcs. Minor arcs are named with 2 endpoints. That's it. A major arc and a semicircle are named by their endpoints and another point on the arc that lies between these. So here I have minor arc, and it is just arc AB. So if I was to write that out, that's arc AB right there. Here, if I wanted to name this major arc, I could say this is ADB. That's a major arc. It is also known as arc BDA. The semicircle here is arc ADB or arc BDA. Anytime we have 3, it's either going to be a semicircle or major arc. Some books will try to confuse you and give you a minor arc with 3 letters, but no, minor arc always uses 2. Anything that is major is going to use 3. So example number 3 says WC is a radius of circle C. Identify arc XZY as a major arc, minor arc, or semicircle. So if I look from X to Z to Y, that is going to be a semicircle. So that is 180 degrees. 3B, WC is my radius of circle C. WZX, is that a major arc? Well, it's W to Z to X all the way here. That is a major arc. Okay, and that is going to be 360 minus this 90 right here. This 90, that's WX. So 360 minus 90 is 270 degrees. And finally, we need to identify XW as a major arc, minor arc, or semicircle. It is definitely a minor arc, and its central angle is 90, so therefore it is 90 degrees. Example number 4. I've got that LP is a radius of circle P. I need to identify LO, arc LO, as a major arc, minor arc, or semicircle. It is definitely a minor arc. And if I look right here, this guy is 90. So that means that LO is also 90 degrees. So it is 90 degrees. LP is a radius. I need to find the measure of MLO. That is a semicircle. If I trace out from M to L to O, it is 180 degrees. And then LNO. So I got to go from L to N to O. This time I'm going to highlight in blue from L to N to O. That's the arc I'm traveling out. That is going to be a major arc. So it is a major arc, and it is going to be 360 minus 90, which is 270 degrees. So you can have congruent arcs. Congruent arcs are in the same circle or in congruent circles that have the same measure. So in the circle or in congruent circles, 2 minor arcs are congruent if and only if their central angles are congruent or their arc measures are congruent. I could find the measure of any one of these central angles because I know that in a circle graph, they all have to add up to be 360 degrees. So basically, I'm just going to take the proportion of that circle and times it by 360 degrees to find its arc measure. So if I look over here, I've got KL. So in order to find that angle measure, I'm going to do 360 times 0.21. If I take 360 and I multiply that by 0.21, that's going to tell me that that central angle is 75.6 degrees. If I look over here and I want to find the measure of arc NJL. So N, J, and end all the way over here at L. NJL. Well, I could take and add up all of those, or I could just find that minor arc, which is 16%. And that is arc in L is 16%. So I'm going to do 360, and I'm going to multiply that by 0.16. If I do 360 times 0.16, I'm going to get 57.6. So then I'll do 360 minus 57.6 degrees. 360 is the whole measure of the circle. Subtract the 57.6, and I find out that the measure of arc NJL is equal to 302.4 degrees. Adjacent arcs are arcs of the same circle that have exactly one point in common. You could add the measures of the adjacent arcs to find the measure of the larger arc. So if I take a look right here, I've got arc AB, and then right next to arc AB, I have arc BC. These are adjacent arcs. I could say that the measure of arc AB plus the measure of arc BC will equal the measure of arc AC, and that's the arc addition postulate. So if you see over here, we've got measure of arc XY plus YZ is equal to the measure of arc XYZ. So the way I like to think about this is, can I go through and fill in all these missing angles? So I know that this guy is 58 degrees. I know that this is a semicircle from C to A, so 180 minus 58. So do 180 minus 58, that's going to give me 122 degrees. So this arc right here is 122 degrees. 180 minus the 32, again, why am I going to do 180? Because it's a semicircle. So 180 minus the 32 says that arc AB is 148 degrees. So I can now go through. I know that arc BC is 32, and I could answer any of these questions. What is the measure of arc BC? It is 32 degrees. If I wanted to find the measure of arc B to D, it's going to be 32 plus the 58, which is 90 degrees. You see right here, B to D is the combination of 32 and 58. What is the measure of arc ABC? That is going to be 180. We know that that is a semicircle. And the measure of arc AB is 148 degrees. If I come over here, I've got the same thing that's going for me. I got 90 plus 32. That's 122. 180 minus 122. I'm going to get 58 degrees for this central angle. So that means arc JK is 58 degrees. Arc IJ is 90 degrees, and HI is 32 degrees. Alrighty. So then if I look over here, I know that these angles right here, I have vertical angles, so these angles are congruent, which means HL is 58 degrees. And then 180 minus 58 is 122 degrees. So what is the measure of arc LHI? Right here, LHI, we're going to say that that is 90 degrees. And the measure of I to J to K, I to J to K. I'll highlight that in a different color for everybody. I to J to K. I know it's a minor arc. This is where I was saying that they could trick you. 90 plus 58 is 148 degrees. So one more thing we could do is we could find the distance between the endpoints along the arc measured in linear units. If we do that, we're talking about arc length. An arc is a portion of a circle, so its length is a fraction of the circumference of that circle. So all I have to do is find the given arc, and I'm going to take that arc length over 360, and then I'm going to multiply it by the circle's circumference. So here I see that the red arc is 240 degrees. So I'm going to do 240 over 360, and then I'm going to multiply that by 15 times 2 times pi. Why did I multiply it by 15 times 2? Because the radius is 15. So remember, I have to use 2 times pi times the radius for the circumference here. So that's going to give me 30 pi. So I have 240 over 360 times 30 pi. Well, that's going to be 2/3 times 30 pi. And that's going to be 2/3 of 30, which is 20 pi centimeters. And I'm finished because it said to leave my answer in terms of pi. In example 10, we're going to round. Here, I know that the central angle is 90, so this arc is 90. So I'm going to do 90 over 360 times, well, this time I have the diameter, so all I'm going to do is times this by 16 pi. So that's 1/4 times 16 pi. 1/4 of 16 is 4 pi inches. So I am finished. That is my arc length. Okay, like I said in example 10, they're going to have me round, and they want me to find dA. So if I look right here, dA is 40 degrees. So 40 out of 360. And this time they tell me that the radius is 4.5. So 2 times 4.5 times pi. So I'm going to do 40 divided by 360. I'm going to get 1/9. So this is 1/9 times 9 pi. All right, well, 1/9 times 9 is 1. So I just have pi as my answer, and pi is approximately 3.14 when we round to the nearest hundredth. And lastly, I need to find the length of arc JL. So J to L, because it's 2 letters, I'm going to use the smallest or the shortest distance. 180 minus 22 is 158. So I'm going to do 158 over 360 times 14 times 2 times pi. Again, R is equal to 14 here. So 158 over 360 is going to be multiplied by 28 pi. Now, 158 divided by 360, that will reduce down to 79 over 180 times 28 pi. So now all you got to do is take that and times it by 28, times it by pi, and we had to round that answer to the nearest hundredth, which is approximately 36.61 centimeters. All right, that's the end of the notes today. Please check Schoology for your homework. I wish you guys a great day. Thank you.